Okay, so we're going to go through this paper. This is being extracted from 2024 GCE Science Paper 1. So the figure down here shows a wave, and then they're saying define a wavelength of a wave. Okay, so I'll create space here to define the wavelength. So we can say this is the distance. Okay, wavelength is is the distance between two successive crest or trough. Okay, that is how you can define a wavelength. Okay, so let's move on to the second one. Okay. State the wavelength of the wave in the figure. So how do we state the wavelength? So let me zoom this wave down there so that we're able to see what. Okay. Okay, so we're going to say 15 minus 5, so which is going to give us 10. So this is the wavelength, 10 centimeters. So just get this number and then that's the number, make sure you subtract them. You're going to get 10, so that is the wavelength. Okay, so done. Let's go to the other one. What is the amplitude of the wave in the figure above? So we are on C. So the amplitude, how do you determine the amplitude? Okay, so the amplitude is a successive displacement of the wave from its resting position here up to there, the maximum displacement of a wave from its resting position. So from the resting position here up to 10 there, that is the amplitude. So we can say the amplitude is plus or minus 10, because we are also putting into consideration of the negative 10 there. So if the maximum displacement is happening on top of on the positive side, it's also happening on the negative sides there. That's why I've put the negative. Okay, so that is the amplitude of the wave. Let's move on. Okay. D. If the wave travel along the string at 0.5 meters per second, calculate the period of the waves in figure above. So the first thing that we're going to do is we're going to write down the data. Okay, we're going to write down the data. Okay, so that's data. So after doing that, so we've been given the V to be 0.5 meters per second. After writing that, let's also find something that we've been given there. Okay, we also have the wavelength, which is represented by lambda. So we calculated the wavelength to be 10 centimeters. So this wavelength is going to be converted into meters. Why? Because the speed that we've been given is in meters per second. V is equals to meters per second. So which means the wavelength should be converted into meters. So what are we going to do? We're going to divide 100 there, which is going to give us that's 0, it's going to give us 0.1 meters. Okay, so that is the wavelength. Okay, meters. So after doing that, we can now use the wave equation formula. Okay, so we can say speed is equal to lambda multiplied by frequency. Speed is 0.5 equals lambda, which is 0.1, and then frequency. When we divide 0.1, so we're going to divide here 0.1, then there 0.1, so that 0.1 and 0.1 can go, and then we're going to have we're going to say frequency is going to be equal to 0.5. When we divide, let me see, we're going to have 5 hairs as frequency. So after doing that, ladies and gentlemen, we can now use this formula to calculate for period, because what they have asked us to do is to calculate for period. Okay, so the paper that I'm looking for is here. So they want us to calculate for period, calculate the period. So after doing that, we can say, we can use this formula. We can say period of a wave is equals to 1 over frequency. Do we have the period? No. So we're going to leave it that way. And then 1 over frequency. How much is the frequency? It is 5. Calculated frequency to be 5. Once we divide that, ladies and gentlemen, you are going to have your period to be 0.2 seconds. So